Alrighty, so let's continue with where we left off on combining complex numbers and writing them out in a plus bi form, so that is in simplest form. So let's just get started. So we have for question 1, remember the highlighted yellow ones we're going to do together, and then the pink ones are on your own. Oh, yo. Okay, so let's take a look at the first one. So don't overthink this, guys. I've seen this actually happen a lot in the past. I'll see people see this as, oh, there's a double set of parentheses, so we should be multiplying. No. Look, there's addition here. Don't immediately assume it looks like this, because this is not what it says. This is wrong. It's not multiplication, it's actually addition. So let's actually add it up. So I'm just going to rewrite. I have 3 plus 5i plus 4 minus the 3i. I'm going to combine like terms. All right, maybe I'll highlight this in green here. And we'll just write our final answer. So I have 3 plus 4. Then I have plus 5i minus 3i. 3 plus 4 is 7. And 5 minus 3i is 2i. And there we go. I have 7 plus 2i. That's my final answer. Don't worry about this picture yet. We are going to be spending an entire unit on vectors. Vectors is actually really one of my favorite units to teach. You are in advanced math concepts, so we do topics that are outside of other courses. So for those of you that did take pre-calculus with me, this will be an entirely new topic for you. Really, really cool stuff. Okay. I want you guys to try question 2. We're going to do 3 together. So let's do 3 together. All right. So, little bit of advice here. I'm just trying to remind you there are some integrated algebra topics in here because I do want to make sure we're okay with the fundamentals. Now, because of this squared here, that does not mean distribute it to both terms. That is a big no. We're going to write it out twice. This exponent here means that there are 2 copies. So I have 2 copies of this. So I'm going to write 1 plus I times 1 plus I. We're going to double distribute. 1 times 1 is 1. 1 times I is I. I'm not writing plus 1i. You guys are above that. Plus I and then plus I squared. I know 1 plus, well, I plus I, that's 2i. Plus I squared. You got to remember, I squared is negative 1. So this is plus a negative 1. 1 minus 1 is 0, so those cancel out, and I'm left with 2i. That's my final answer. I will just write the answer for question 2. Now, guys, listen, I make mistakes, so if you think that, one of the answers that I post here is not correct, shoot me an email, let me know. Maybe I'll give you a bonus point for catching a mistake. Okay, but again, you need to show me the work. I want to see that double distribution, and in the end, you should get negative 11 plus 23i. All right, moving on, let's do question 4 together. So for question 4, I just want to know what's the conjugate. So this should be nice, plain and simple. The reason why people tend to get this confused, so the conjugate, is they think, oh, it's all the opposite signs. No, all you do is change the middle sign. But now be careful. It needs to be in a plus bi form. So that when you change the middle sign, so when I change that middle sign, it will be a minus bi. Be careful. I think I did throw a question in there like this where I have it written like this, like 9i plus 8. This is wrong if you write 9i minus 8. It needs to be in a plus bi form. So this is actually wrong. You would need to say, oh, hey, this is actually 8 plus 9i. Rewrite it. And now I know, switch the middle operation to subtraction. And that's my final answer. So it is 8 minus 9i. All right, be careful of this. Make sure it's in the a plus bi form order. I believe I do throw that somewhere in addition on a quiz. So be on the lookout for that. Okay, question 5. We are going to do this one together, and you guys are going to do question 6 on your own. All right, so question 5, nice and easy. Sorry, I gave you the harder one for question 6. Just remember as your little hint, you should be multiplying for 6. Multiply top and bottom by the conjugate of the denominator. Make sure it's an a plus bi form. Okay, sorry if that's a little sloppy, but that says multiply top and bottom. Oh boy. All right, so multiply top and bottom by the conjugate of the denominator. So that's your little hint for 6. Your final answer for 6 ends up being -1 plus 23i all over 53. But you got to show me the work. Okay, so for question 5, like I said, we'll do that one together. Just going to distribute, nice and easy. 7i times -5 is -35i. And 7i times 2i is 14i squared. Remember, I squared is -1. So really, this is what we're left with, but I want it in a plus bi form. So this is -14. So this is not the correct order, so I'm going to rewrite this as -14 minus 35i. And there's my final answer. All right, so far so good. Let's take a look now on the next page. We're on page 12, and I'm going to do question 7 with you. You're going to do question 8. Okay, so for question 7, again, multiply top and bottom by the conjugate. Make sure this is an a plus bi form. Hint, hint for question 8. Make sure it's an a plus bi form when you multiply by the conjugate. So I'm going to multiply top and bottom by 1 minus 2i, 1 minus 2i. And that gets distributed to everything. So this is really going to be 8i minus 16i squared all over. I have 1 times 1, which is 1. 1 times -2i, which is -2i. 2i times 1, which is +2i. And 2i times -2i, which is -4i squared. Okay, almost there. We have 8i minus 16 times -1, right? Because I squared is -1. These terms are going to cancel, which is what we wanted. That's why we multiply by the conjugate. That's the whole point. Now I have 1 minus 4 times -1, because again, I squared is -1. So I have 8i plus 16 all over. This really is 1 plus 4, so that whole thing is 5. And that's my final answer. For question 8, again, just posting the answer. You need to show all the work. This is my final answer. Okay. Again, you got to show the work. All right, let's move on. I will walk us through question 9, and then you guys should be able to do 10, no problem. That should be actually really quick and easy. All right. Okay, so we're just going to start to double distribute. So I have 2 plus 2 radical -36. I have minus the square root of -100. And then I have a negative times a positive, which is a negative. I have the square root of -100 and then the square root of -36. Okay, so I'm just going to start to see what I can simplify. Because these are negatives under the square roots, we know that these are imaginary numbers, all of these. Just keep that in mind. So there has to be an I. All right, so I have 2. Let's see, I have 2 plus 2 times. Well, the square root of 36 is 6, but there's the negative out front, so it has to be 6i. Minus, again, the square root of 100 is 10, but there's that negative here, so it's 10i. Minus, again, square root of 100 is 10, but we have a negative under the radical, so it's 10i. And then lastly, again, we have the square root of 36 is 6, but there's an I, so there's an imaginary value because of the negative underneath, so we need to include that. Okay, and now we're just going to start to simplify. I have 2 plus 2 times 6i, so let's multiply here, right, following PEMDAS, so that's 12i minus 10i, and then this is minus, well, let's see, let's multiply these. 10 times 6 is 60i squared. All right, let's keep going. I have 2 plus, let's combine like terms. 12i minus 10i is 2i minus, this is 60 times I squared is -1. So I have 2 plus 2i, this all together is positive 60, and I'm left with 62 plus 2i, leaving that in a plus bi form. Alrighty. And for question 10, I'm not even going to post the answer because there is no work to show. So for question 10, you guys need to do that. There's no work to show. There is just one response. All right, so let's move on into what our next lesson actually is. Our next lesson is adding and subtracting polynomials. We're going to get into factoring. I'm going to show you guys other ways to factor because, again, we're not in a Regents-based course. I can show you guys other ways to solve and perform operations on things. So first things first, let's just establish some terminology. This should all be, like, nothing here should be new. This should just be review for everybody. Okay, so starting off with our very first definition, we know that a polynomial, so a polynomial is just the sum, so sum is addition, sum of monomials. We know a monomial, okay, is just a number, a variable, maybe it's the product of numbers or variables, but it's just one term. So this is just one term. Okay, the way you guys can think of it is like polytheistic. If you're polytheistic, you believe in many gods. If you're monotheistic, you believe in one god. So that deals with kind of like social studies. Maybe that could help you remember those terms. But again, this should be review and nothing new here. Okay, binomial deals with bi. Think about like a bicycle. There are two wheels on a bike. There are two terms. Tri, think of a tricycle. There are three wheels on a trike. And just a monomial, it's just a singular term, which we call by combining like terms. You'll end up with a monomial when you combine like terms of the same, concept. Whether it's like all the variable x together, or it's all constants together, you'll end up with just one term, a monomial. Okay, moving on with our definitions. The degree of a polynomial, that's just the highest exponent. Okay, so that's the highest exponent of any term in the polynomial. The leading coefficient is the term with the highest exponent. So it's the coefficient of the term with the highest exponent. Let me rewrite that. Okay. Okay, moving on. We know a constant. So the constant is just the number that has no variable attached to it. So that could be like the number 2, the number 5, the number 10. But like 10x, that's not a constant because of the variable. And then lastly, we write standard form of a polynomial where the exponents are in decreasing order. So in decreasing or descending order, where it goes from high to low. Okay, all definitions that you should already be aware of. So let's take a look at some examples. So just for the first example, I want to rewrite this in standard form. I want to know what is the degree, leading coefficient, and then the constant. So the degree, we want to look for the highest exponent, and I see it right here. The highest exponent is right there. It's a 6. So this term, right? Now, the leading coefficient is always attached, right? I already said this earlier. The leading coefficient is attached to the term with the highest exponent. So 3 is my leading coefficient. The constant is the number that's on its own, which is this positive 7. And now if I want to write this in standard form, we need to go from decreasing from high to low order. So we have that 3x squared, at 3x to the 6th first, and it goes from the highest to lowest in the order of the exponents, not the coefficients, the exponents. So I have 3x to the 6th minus 2x to the 5th plus x to the 4th, and then plus 7. Okay? You guys are going to do question 2. Again, I'm not going to write the answers here because it's very self-explanatory. There's no work to show. So we can talk about that in class if you have questions. And then for question 3, again, we need to look what is the degree of the polynomial. So where is the highest exponent? Right there. So the degree is 3. The leading coefficient is always attached to the term with the highest exponent. So again, the number out front here, because it says plus x cubed, there's really an invisible 1 out front, so that leading coefficient is 1, not the negative 2. A lot of people get confused when they say leading, they think it's the very first number. That's not true. Okay, constant, this really is just plus 0, so the constant is 0. I don't see any other numbers here, so it's just plus nothing, plus 0. And then I'm just going to rewrite this in standard form. Okay, and that is my final answer. All right, let's move on to our next page. Again, this should all be review, practice, things that you guys should already be comfortable with. So this should be like a nice first unit, like nice easy lesson for us today. You guys are going to do question 5 and I'll do, let's see, you'll do 5 and I'll do 6. All right, so for question 6, I'm going to rewrite this. I'm going to highlight like my like terms. I think it's just easier. So I have this 18x squared with this positive x squared. Remember, you guys always include the operation out front. I have negative 9x, which compare with that negative 7x. And then lastly, I have 12 is on its own. And oh, look, I forgot one. That negative 5x as well when we combine like terms. Okay, so I'm just going to rewrite this out. We have 18x squared plus x squared minus 9x minus 5x minus 7x, and then that plus 12 is on its own. All right, let's start combining. X squared plus x squared is 19x squared. Negative 5x minus 7x is negative 21x. And then we just have the plus 12. And notice that this is written in standard form. All right. I'll just post the answer for 5 because you do need to show the work. You should get negative x squared minus 10x. Okay, moving on. Let's just get some more practice. Okay. All right, so I'm going to do question 7, and you guys are going to do 10. So for question 7, I have f of x, which is in red up here. And then I have plus g of x, which I wrote here in blue. So that was here. All right, so we're just going to combine like terms. So I'm just going to write them out. We have f of x is that x squared plus 3x minus 1 plus 3x squared minus 4x plus 6. And again, I'm going to color code this for combining my like terms. Again, you guys should be very used to this already. This is nothing new. I have plus 3x minus 4x, and then I have minus 1 plus 6. Okay, so when I just reorder this, I have x squared plus 3x squared. I have plus 3x minus 4x, and then I have minus 1 plus 6. All right, now just going to combine my like terms. This is 4x squared minus x, and then I have here that negative 1 plus 6, which is positive 5. Okay, and then that's my final answer for 7. For question 10, I'm just going to again post the answer, but you guys need to show the work. All right, let's flip over to the next page. We're going to take a look now on page 15. So I'm going to do question 14 with you guys, and then I want you guys to do all of 15. So A plus B plus C, etc. All right? So for question 14, I'm just trying to wrap this up quick, so I'm going to move a little quickly here. We have the following. So we have 4x cubed, etc. This whole thing is being then multiplied by 4. So I'm first going to combine my like terms in here. So I have 4x cubed plus x cubed minus 2x minus 3x plus 8 minus 5. Combine like terms, that's 5x cubed minus 5x plus 3. Multiply it all out by 4. So we're going to distribute into everything. And we end up getting 20x cubed minus 20x plus 12. So that is my final answer. And notice I want it in standard form. I believe Delta Math does mark it incorrect if it's not in standard form. Yes, it definitely does. And very lastly, I'm just going to post the answers for these. But again, you need to show me the work. If you catch a mistake, let me know. Like I said, I'm not perfect. I do try to make sure I check these over. But if you catch a mistake, you think I'm wrong, let me know. And maybe I'll give you a bonus point. And here we go. These are all of the answers once you've done them. All right, guys, hope you found this video helpful, and we'll talk soon.